Hi, I'm Bhagee, and today we're going to learn how to bend. Now, right now, you're probably thinking two things. First, who is this girl and what is with her awful reference to TV shows' theme music, and what does bending have to do with anything? Well, for a start, there are some things you shouldn't bend, like popsicle sticks and bone, because that hurts. But on the other hand, there are things that have to be bent to work, like proteins. Protein folding is what allows a protein to function in the cell the way it does. Have you ever heard of CRISPR? Genome editing? Designer genes? That's only possible because the CRISPR protein is folded in a specific structure called the zinc finger. This allows it to selectively target regions of DNA in specific cells and edit those regions of DNA specifically. So why should you care about protein folding then? To be honest, protein folding is way more than designer babies and lab-created superhumans and trying to make the next Iron Man. Protein folding is very important because in the decades to come, it will be increasingly important to treat disease on the molecular scale. We can already see this with degenerative diseases, especially diseases where cells have problems in their membranes, are permanently inflamed, or have problems in how often and when they divide. This can cause serious effects for the patient, which includes extensive scarring and fibrosis that causes extended amounts of pain. So let's take an example. Let's take a look at a muscle cell. Studies of muscle cells have proven that they have a special protein called MG53, and it's in the TRIM family of proteins. That just means that it works in units of 3 to get to signal together. MG53 signals to other proteins to regulate how often the cells divide and the levels of other protein factors in the cell that are important for its survival. This allows it to maintain a steady state. What happens, though, if this protein isn't folded correctly? One of many things that can happen is that the cell can permanently release inflammatory chemicals and no longer activate cell division and have a grip on the vital protein factors it needs. So the cell dies and muscular dystrophy occurs, causing extensive scarring that's very painful to the patient. What could happen, though, if we folded it in different ways? Is there an optimal way? Can we fold it within the cell using one drug without expensive gene therapies? We can. Researchers from Rice University are using zinc finger proteins as editing tools to control how transmembrane proteins in cystic fibrosis are built and folded. This is amazing because it could help prevent certain death for thousands of patients across the world on the waiting list for lung transplants. Protein folding is a truly groundbreaking field that can help us overcome many more obstacles that we face in treating rare diseases right now. And that's why we need more people studying the chemistry of protein folding, because this could cause the next medical revolution after the invention of penicillin. Thanks.